So we can find slope. We can find the slope of a line. Even if we only have two pairs of coordinates for 2 points on that line. And the way we're going to do that is with a formula that we'll get to here in a second. So the formula here is going to be slightly confusing, but we're going to figure out how to make it work. The slope formula is m equals y2 minus y1 divided by x2 minus x1. A lot of y's and x's and 1's and 2's. We'll figure out what each of those things mean in a second. But with your two colored highlighters, I want you to take your first color, whichever color that may be. You're going to highlight y2, and you're going to highlight y1. You're not going to highlight the minus sign. You're just going to highlight y2 and y1. And then with your second color, of course, you're going to highlight x2 and x1. Guys a little time to write that. And we're going to get our steps written out here. Yes. Sure. So our step one is going to be label each coordinate with a variable. I'm going to move this down. We're going to label them left to right. x1, y1, x2, y2. Step 2, we need to replace each variable in the formula with open parentheses and keep the minus signs. We'll see what that means once we get to it. We're just getting these steps down first. The reason why I like doing these steps for all these lessons is so that if you get stuck on one of these problems, let's say on a homework or a test, you can just follow this step by step and basically reteach yourself these ideas. Now, I know that's easier said than done, and it does take some practice. But it's a lot easier to go through, okay, step 1, I just got to label each of my coordinates from left to right, x1, y1, x2, y2. Okay, I did that. Now I just need to take out all 4 of these variables, replace them with some parentheses, and keep those minus signs where they're at. Seems simple enough. I can do that. Step 3 is going to be plug in each coordinate to its corresponding spot in the formula. Move this down. Hopefully we've all got the formula by now. Formulas are kind of like machines, right? Or think of it like a bike, right? A bike is a type of machine. So if you put the wheels of your bike, if you screw them in where the handlebars go, it's probably not going to work the way you want it to work, right? So we can think of a formula in the same way. Whatever number, let's say it's 3. If we say, okay, 3 is my x1. We have to put that 3 in the exact same position that our x1 is at. If we don't, it's not going to work out how we want it to work. Okay, so we're essentially putting this machine together, coordinate by coordinate. If everything is where it's supposed to be, we'll turn that machine on, and it'll spit out or produce a slope for us that's nice and accurate, without doing a table, without doing a graph, any of that. This is our third different way to find slope. After we plug in each coordinate to its corresponding spot, that just means where is it supposed to go, right? y2 is supposed to go first. Solve and simplify completely. That's our last step. As always, we want to simplify as much as we can. I'm going to give you guys time to finish writing that and let it soak in before we take a look at this in action. All right, let's go ahead and take a look at an example. Let's say we've got 2 points, 1, 4, and 2, 6. No graph, no table, just 2 points. We're going to be able to find the slope with just these 4 little numbers here. What's my step 1 going to be? What do we have to do first, Evan? Perfect. We're going to label each coordinate from left to right just like this. x1, y1, x2, y2. So the way that we're going to visualize us doing this is with our highlighters, okay? Whatever color you chose for your x's, take that. I'm using purple, but whatever color you have for your x's down here in your denominator, okay, whatever color you used in the denominator of your formula, we're going to highlight our x coordinates, all right? Which of these 4 numbers, there's 2 of them, which of these numbers is an x coordinate? Devin? 4? 1 and 2, right? It always goes x first, y second. So 1 is an x coordinate and 2 is an x coordinate. We're going to label those x1 and x2. Now, those 1 and 2s that we see, they look like exponents, right? They're tiny little numbers. But why are these not exponents? Where do exponents go? Up on the top. These are not on the top. They're on the bottom. What these 1s and 2s here are called is a subscript. Okay? Subscript. It just means that we've got the first x coordinate and the second x coordinate. It's a way to distinguish between the two. So what are my y coordinates going to be here then? If 1 and 2 are x coordinates, what are my y coordinates?
4 and 6.
4 and 6. Boom. Boom. With your second color. Whatever you use for your y's, you're going to highlight those. And we're going to call them y1 and y2. Just like that. So this means we have the x coordinate for the first point and the y coordinate for the first point, x1, y1. We've got the x coordinate for the second point and the y coordinate for the second point, x2, y2. Your 2 points are always going to be written out like this, so you can always just label them in this order: x1, y1, x2, y2, x1, y1, x2, y2. Give me a thumbs up if the way that we labeled that makes a little sense. Okay, once we get some practice, it'll be clearer. That was our step 1 right there. All right. Step 2, we're going to take our formula, m is equal to, but we're going to replace each variable with open parentheses. So instead of y2 minus y1 on the top, we're going to have open parentheses minus open parentheses on the top. Looks like kind of like one of those big-eyed goldfish with the big bulging eyes and the little mouth. 2 open parentheses, minus sign in the middle. Same thing on the bottom. So we're taking out those variables. We're going to sub them in here in step 3 with these numbers. So take a look. This very first variable that we took out here, what was that variable in the formula? Y2. So which of these 4 numbers, 1, 4, 2, or 6, which one is my Y2? 6. That's going to go right there. And I'm going to highlight it. After y2 comes y1, which was 4. So we'll plug that in on the top and highlight it as well. Okay, I'm going to take a second there so you can see what we did. Now, what's my first variable on the bottom here? x2, which in this case is equal to what? 2. And finally, we've got x1, which we labeled as 1. That's the hardest part right there, is figuring out which number goes in which place. It's like a 4-piece puzzle, right? If I gave you a puzzle that was only 4 pieces, wouldn't be too hard to put together, right? Comparatively to, 100-piece jigsaw puzzles or anything like that. 4 pieces, you can figure out which corner goes where, and that's what we're doing here, is we're filling out this puzzle. There's step 3, filling in all those numbers. Step 4 says we've got to solve and simplify. So we're just going to take these numbers on the top and subtract them. Take these numbers on the bottom and subtract them. M is equal to, what does 6 minus 4 give us? 2?
3.
6 minus 4?
Oh yeah,
2. 2? And what's 2 minus 1 give us on the bottom? 1. What is 2 over 1 equal to? 2. So our M is equal to 2. And that's our answer there. What's that? How did I get what? How did we get the 2 over 1 here? Good. So we just solved, right? The numerator says 6 minus 4. Well, 6 minus 4 is 2. The denominator says 2 minus 1. 2 minus 1 gives us that 1 there. See how we got that fraction? And then we just simplified from there, right? So solve and simplify. We're going to do a couple of these, don't worry. I'm going to have to flip mine over to continue, so make sure you finish getting this written down. Looks like we're good to go. If you missed something on there, just let me know. We'll go back at the end. Second example, let's say we've got 3 comma 4, and we've got, I don't know.
2.
No, give me something larger than 2.
5.
5. What else?
6.
6. Okay. Doesn't really matter, but we'll go with that. 3 comma 4 and that's just 3, 4, 5, 6. All right, that's fine. 3 comma 4, 5 comma 6. The first thing we want to do is label. So I'm going to highlight my x's. What are my x coordinates here?
3 and 5.
3 and 5. What are my y coordinates here?
6 and 4.
4 and 6. Boom, 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 boom. So 3 is the x coordinate of my first point. We'll call it x1. 4 is the y coordinate of my first point. We'll call it y1. 5 is the x coordinate of my second point. We'll call it x2. And 6 is the y coordinate of my second point. We'll call it y2. We're going to set up our formula, but instead of those variables in there, we're going to have open parentheses. And we'll see why that's important in the next example. Not so much these first two, but in the next one with our negative signs, we'll see why we're doing those parentheses. I know that I'm going to have y's on the top, so I did those in yellow. I know I'm going to have my x's on the bottom, just like that. Yeah. How come the y what? How come the y goes over the x? I'm not sure exactly why, but it's a common theme whenever we're doing this slope stuff, right? Rise over run, that's the change in y over the change in x, right? When we talked about at the very beginning of this unit, the constant of proportionality, k, we brought up that phrase, why aren't you over your x? Because we put y over x, right? You remember that? So anytime we're doing this, the y always goes on top and the x always goes on bottom. But I'm not exactly sure why specifically, like how the ancient mathematicians discovered that. I'm not sure. It's a little above my pay grade, but I appreciate your curiosity. Just remember the y's go on top, x's go on bottom. I think it has something to do with Pythagorean theorem. No, it has something to do with triangles.
Doesn't matter. Doesn't matter if the 6 is going to be 4 or it goes 4 to 6, right?
So the first number here is going to be y2. What was my y2 value? 6. What was my y1 value? 4. So the really important part of this is keeping everything in order. Because if we flip the top two numbers, but we don't flip the bottom two numbers, we're going to get something super, super different. Okay? Now you may be thinking, well, what if 5, 6 was written in front of 3, 4, and we labeled it opposite? Don't worry about that. That'll be too confusing. Just keep it like this, left to right, x1, y1, x2, y2. It's the easiest way we can do it. So what's going to go right here, x1 or x2? x2, which is what? 5. And right here is going to be our x1, which is 3. Essentially, what we're doing is the exact same thing as what we did with our tables. We're asking, how do we get from 4 to 6? And how do we get from 3 to 5? Right? How would we get from 4 to 6? From 4 to 6?
Oh, no.
Plus 2, right?
Oh.
Just like how 6 minus 4 is equal to 2. How do we get from 3 to 5?
2
Plus, good. Plus 2, 2 plus 2. 3 to 5 is plus 2. So 5 minus 3 is also positive 2. Exactly right. The same thing as our table, just represented in a little different way. Yes, sir?
Since this book too can make it into one.
Absolutely. That's going to be our last step, is to simplify. 2 over 2 is always going to be equal to 1. There's our slope for that one, positive 1. All right, let's do an example that's a little bit trickier because we're going to throw some negatives in there. Let's say we've got 3, negative 2, and negative 1, 4. What's the first thing we need to do with our points? We're going to label them, exactly. So 3 is my first x value. what label can we give that 3? If it's my first x value, x1. Negative 2 is my first y value. What can we label that one as? Y what? Y1. It's my first y value. Right? Our little subscript numbers have to be in the same point. So 1 and 1, 2 and 2. Negative 1 is my second x value. What can we call that? x2. And 4 is my second y value. What's that last label we're going to give it? x1. Second y value, y2. Right? I'm going to highlight my y's, highlight my x's, just so I know I'm putting those in the same part of my fraction. Good morning. Thank you. And then I'm going to set up my formula. Now this is where the parentheses are really going to come in handy, because we don't want to mix up these minus signs with any of these negative signs, okay? I'm going to focus up on this one here. Good morning, Ashley. Come on in. Thank you. All right, so what's going to go in this very first parenthesis here? Take a look back at our formula. What's going to go in this first parenthesis here? Someone tell me. 4, because it's our y2. What's going to go next to it? Negative 2. Good. Down here, what's my first point on the bottom? Negative 1. Not 3. It's x2 minus x1. And what's going to go in this last parenthesis here? Positive 3. Good. My x's are on the bottom. My y's are up on the top. That's what we want right there. Now, what do we see right next to each other on the top here? 2 negatives, right? Whenever we see a minus next to a minus, what do those come together and form?
Positive.
A positive, that's right. So we've got 4 plus 2 on the top, negative 1 minus 3 on the bottom. Right, those 2 minus signs make one big plus. Now we can go ahead and solve. What does 4 plus 2 give us on the top? 6. Now think about this carefully. Negative 1 minus 3. What's that going to give us? Take a look at your number line and walk it out. Start at negative 1. Subtract 3 to the left. Where do you land? Did you go to the left or to the right? Let me explain what I'm talking about, because we don't know what I'm talking about. If you start at negative 1 and you're subtracting to the left, 1, 2, 3, where do you land? Negative 4, okay? This integer stuff, guys, we have to just get down by now, okay? Negative 4. I'll say it every single time. If you spend $1 and then spend $3 more, in total you spent $4. Okay? 6 over negative 4. If we bring that down to simplify, 6 is 2 times 3. 4 would be 2 times 2. We know that it's going to be negative out in front. I'm going to bring this down. What can we cancel on the top and bottom here? Pair of 2's go away. M is equal to negative 3 over 2. And we can have a fraction, right? Slope is should always be a fraction, technically, if we're going to be graphing it, but totally fine if we have a fraction. We're going to get some fractions on our worksheet here in a couple minutes. What questions can I answer about that one? Because I know with the negatives, it's going to be a little trickier. You guys got this part down, the 2 negatives next to each other make a plus, right? We have to remember, when there's a negative number minus a number, we get a bigger negative number. All right?